welcome to today's live stream. Today we're building the MX69 version 3. I'm using the OL51F board and the, I think it's a 337AF display, the pigtail, one cam, unedited V3. I have the MX69 version 3 board, the MX69 version 3 housing, the 5-volt boost converter, 3 pins, I'm not sure what they're really called, got some clippers, multimeter, some tweezers, a soldering iron, and that's pretty much all you're going to need. You're going to need some glue as well. I'll probably just, you'll see what I'll do, but I'm going to remelt some hot glue with my hot air station to glue the screen in place. I find that super glue will permanently glue that screen in place, and if you want to remove it, you'll actually destroy your display. So that's not the best, because if you mess up like an alignment or something, it's stuck, and if it's stuck there, it's done. So we're going to use the OL51 has a different pinout than the old V760 displays. Here is, let me pull the stream up so I can see, but the pinout's a little bit different. The old pinout, for your reference, is shown here. It should look just like that, the old pinout. I'm sure that's probably not a good example to show it, but all these things are posted up in the Discord. I pinned them in the previous 69 chat so you can see, but the cable is white to video, blue to ground, green to hot. Just take note of the pin numbers. So this is 5, 6, 7. The pin numbers are. So 5, 6, 7 is video, ground, hot, and that's for the old V760 boards. I don't have one on hand to show you, but that's the old style board that doesn't look like this. It looks significantly different. It looks like the old board. I'm going to pull up the Buildstream real quick on my computer to my left. Let's see. Alright. So let me look at some comments and stuff too. Yes, there is kits. So I know my ship times have really been terrible, but that's a lot better now. I still have some alpha kits to catch up on, but mono kits, MX69 kits, and battery pack kits ship pretty much next day. I'll have them packaged same or next day, and then they'll go out whenever I get enough to actually take to the fucking post office. So this is the pinout. Let me get this spot where you guys can see it. So that's the pinout for this board. You see, we're going to use pin 9, pin 8, and pin 1. Those are the boards we're going to use. We're not going to use pin 6, which is the video ground. Pin 7 and pin 10. I'll show you what to do. We're going to want to save a couple of these leads in case we need to use pin 7 and pin 10. Those are the brightness adjustments, and I've actually seen where sometimes these displays, they come in and most of them are all the same setting for brightness, but some will come in, they're just very, very dim, or they're like so, I don't even know how to explain the light that comes off them. The light that comes off like burns your eyeballs when you look at it. So we'll use those pins to adjust it to what feels right. It's not going to do much for the actual night vision ability of them. It just is about the comfort and the feel on your eye. You don't need it super bright because it's, you know, a night vision unit, right? There's not much ambient light, so a nice mid setting is fine. Whereas daytime, you know, you want to crank it up to defeat the daylight rays. All right, so I'm going to look at this bag real quick and see that our connector matches up with the image on the connector. Pin 1 is red, so for our purpose, red is going to be our video. Let's see. 10 pin connector, so pin 10 is brightness, pin 9 is ground, brown is ground, and purple is VCC. What we're going to do is we're going to take black, yellow, green, and blue. And because these ones are not connected, this is pin 2 through 5. We're actually just going to snip these off. And the reason we're snipping them is because they'll provide a little extra, like the actual connectors will provide extra like strength for holding this board into the socket. But for pin 10 and pin 10 and pin 7, what we're going to do is we're going to take some tweezers and we're going to go on this top side. We're just going to jam, let me flip my glasses down. We're going to jam these tweezers into this socket. And once we can kind of see that we're lifting up the tab, we're just going to pull on the wire and the tweezers. There you get it. And we're going to pull it out. So I'm pulling the orange wire. We got the tweezers in the socket with it. And so that way we got the actual connector out in case we need to use that connector later on. But in the chance that we don't, I just normally pull this one out, and then if we need to use it later on, we'll reinstall it. It's just, you just push it in, so it's not a big deal. Alright, there's our 2 spare leads, we'll call them. So now we're left with our 3 pins. We're going to go ahead and open up our run cam, and set that cover aside. Pull your camera out. Then you're going to pull your control board. Let me know if I'm not, yeah, you can barely hear me. Alright, so you pull your control board out, and you pull your connector out. The hum, I'm sorry, that's fucking from my, what is this? Let me see. Be right back. Alright, hopefully that hum went away. Sorry about that. That is the old house fan, or whole house fan. Alright, so from your night eagle, you're going to have throw these screws away. You don't need those. Throw the box away. You have your night eagle, your control board, and your pigtail. So with this pigtail, I see a lot of people do this, and then they're like, "Oh shit, what do I do?" Don't just clip the whole thing. Separate out the OSD wires like that, and then what I like to do with my sausage fingers is I'll compare it next to my finger, and I'll go like two of these grooves in, and I'll cut it at the end of my finger, so right there. I think that's probably going to be about 2 inches. That's where I'll cut it. And that should be just short of the actual OSD itself. And I'm sorry, I'm hearing a lot of like spring noises. It's my freaking camera gimbal system. I do have a mic, but it doesn't work with my fucking phone for whatever reason. Anyways, so here's that connector for the camera. Here's our connector for the display. For the display, we're not going to cut it quite as long as the camera. We can cut it a little bit shorter because this basically just comes off the board and wraps around like that. So I'm actually just going to do about 1 knuckle. Set this off to the side. I'm going to set our display over here just so it's out of the way. And then we're going to look at our board. So as you can see, there's a video, a ground 5 volt and 3 volt connection. So our display can connect to either 5 or 3 volt. Lately I've been actually putting it on the 3 volt, and it's gotten to be a little bit more efficient. Not a crazy amount to really make a difference, just a little bit more efficient and a little bit lower startup voltage. So we can potentially get away with using disposable CR123s instead of the rechargeable ones. Is this frozen? It's frozen on my computer. Yo, is this frozen for you guys? You see that? Waving my hand. Alright, not frozen. Alright, let me just refresh my computer. Alright, like I was saying, these are your connections or whatever. I've been getting away with putting it, the screen's power, our purple cable is going to connect to that 3 volt, and that's letting it start up at a little bit lower voltage, and we'll run some tests once we get done building this one. Someone said, is that the clip-on? Yeah, it's kind of a weird clip-on prototype, and here's another weird clip-on prototype. I haven't put them all together yet, but this is like the newer version. I just got tired of rubber banding the batteries to the side of it, and I just put some little holsters on the side. The problem I'm running into is the thermal draws so much power, it puts this boost control module into thermal shutdown. So it'll run for 20 seconds and turn off. And it's a pain in the ass. So I'm trying to figure that out. Maybe put them in parallel, but I heard that doesn't actually do anything. So I don't know. I'll figure it out. I'm gonna try some higher quality ones first. But what I'm gonna do right now is I'm actually gonna tin up all these pads, and I like to put a nice little bead on there, just to give something for the wires to easily just dip into. And just tin those pads, don't tin the 2 big ones. Those are your contacts. And then we're going to take our pins and we're going to put them into this board. And this part I kind of do in 2 steps because it can be kind of a pain and it gets really fucking hot. You can use a helping hands for it, but I don't typically do that. What I do is I'll just kind of get some solder close. Tap the solder. I'll try and just solder 1 pin. The solder line's a little fucked. Tip's kind of dirty. Once you get kind of a solder on 1 pin, enough that it'll hold this in place, then you can go ahead and solder the rest of the pins down here on the table. I'll just leave it up on this board, just keep it flat. Sorry, I have 0 depth perception right now because I'm using these dentist glasses, but they're not good dentist glasses, so they kind of, I got 0 depth perception when I'm doing this. I'm just going to start poking around until I hit it. But it's like a nerf, you know? I'm nerfing my soldering skills. And I would drop it straight on the floor. And a second time. Alright. Here is this. Why the fuck's it froze for me? It's frozen on my computer. Alright. I can't tell if you guys can see this real well or not. But it's soldered on there. And what we did is the black part kind of separates it. There's a short and a long end. Our long end's now sticking up, and I grabbed some big pliers to cut this part. And I'm gonna cut this away from the camera because I do it because these pins come off like rockets. I was actually looking at it when I snipped it, and it stuck into my lip, like a decent amount. So it's pretty dangerous when you cut these. They come off with some force. I'm gonna cut it under the table. I basically just cut it exactly to the height of that coil because it does not need to poke through very far. And then when you look at your board, you'll see V out, and you'll look at the small board, and you'll see a VO. You're going to go coil side to the board, and you're going to insert that like that. And then you're just going to pinch it with your fingers, and you should see some pins poking out the top. Just like that. And they don't have to poke out too much. You can bend the board to get them to poke out a little bit more if you need to. And like I said before, we're just going to get one kind of in place, and then we'll solder the rest. Don't try the middle one first, because that's the ground, and this whole board has a ground plane. It'll get very hot very quick. So, got that one kind of in place. Now we can go ahead and solder the other two, and then come back to the first one. I need that soldering iron that's got that auto feed to it. That thing looks pretty badass. Alright, so now we have our 3 connections. This one's kind of got a little too much solder on it, so let's see if I can pull some of that off. Alright, we got our 3 connections soldered on there. Don't tug on these too hard. They're a little bit stronger than the old boards. The old boards you could rip out pretty easily. These ones are a little bit stronger, but still don't pull on them very much. You're still going to rip them. Now what I'm going to do is I just have some offcuts of hot glue. Basically, this is just shit that is lying around or was used on the project. And I like to just use these instead of reheating every time. But what I'm going to do is you don't need too much. You only need like a little bit. I'm just going to put a little bit on the back. Way more than I need. Cut this down. Just a small chunk of glue. And I'm going to put this on the back. This is just purely to keep the pins insulated. And I have to not blow it away, so I have to go at it lightly until it starts getting sticky. And this is just using my hot air melt station for soldering. But you can just put a little drop of hot glue on the back, or if you're up for the fucking mess, you can use some epoxy. And yeah. Basically, I just want to get it covered onto those pins. I'm going to try to speed up a little bit. Just to blow it across those pins. It's not getting glued to anything, it's just covered. Alright. And then I like to take some small cuts and drop it in here on this other side. Just get little chunks in there. And I'm just basically trying to give the board a little bit of support, so that way it doesn't rip off and pull your connections out with some slight bending and stuff. these wires, I'm going to strip them the tiniest amount. You don't even need more than like 2 millimeters of wire sticking out of here. Just barely strip these wires out, and they're going to, the casing is going to recede back a little bit, but you really don't need much wire at all. But this casing recedes back. And then I'm going to tin these just a little. Just to prevent it from fraying. I'm going to go ahead and switch the lenses out for my glasses real quick. Just to give me some more zoom. Listen to this. Alright, that should be good. That's a good magnification. And then our camera, we're going to strip these back a little bit as well. I noticed the V2s don't actually have a VBAT anymore. There's no option to turn it on. So voltage monitoring is pretty much gone. I stripped these ones a little longer than I would like them, but that's fine. I'm just going to twist them and tin them. Alright, these are all tinned up. And that's just going to help when we go to solder these boards. That solder is going to melt quicker and it'll adhere a lot quicker. And what we're going to do is we're going to cross our brown over our positive to get our positive oriented in the right space. And we're going to start with our positive pin. And this one's going to go pretty much straight up over the solder pad. And this does kind of matter, so put this pin straight up. So that way when we fold it, because it has to fold down, it'll create an arc loop and not contact the 5 volt and pretty much short the boost converter, I guess. And then we're going to do the same with the ground pin. And the same with the video pin. So now that's rest position is kind of straight up, and the wire itself we're going to have to bend. You don't want it to bend the solder joint, you want it to bend the wire itself, and it'll make that shape right there. Now these ones, I'm going to take our VBAT wire, even though it doesn't matter. I'm going to cross the VBAT over to the positive. I'm going to kind of tighten those together. Just going to tap these with what solders on the iron, and these should be connected. This gets so hot that it's not hard to put it on. Those should be combined now. And now we have our voltage, ground, and video, and our OSD. We're going to pull that to the side and kind of kink it. And we're going to loop this back up so it's not in the way. Oh, no, we have to put this down. Yeah. Because our camera wire is going to go over top. But we're going to start with the video and try and hold them kind of both in place so they're not moving. And you can twist these together every time you soldering, but I like to do it this way purely for the orientation of the wire coming off. And we're going to look around. Then we'll do a 5-volt. And you want to keep your camera connected on top. Alright, that's your connections for the OL51. And push my solder off to the side for now, so I need it. And we'll talk about our camera real quick. So you're going to take a small Phillips screwdriver that, I don't know, I got around here somewhere. Your tiny Phillips screwdriver. This is a PH 00 number 2. Whatever that means. And we're gonna take these 4 screws out. And I believe the new version of the MX69s have all 4 holes. That eliminates that old effect that we were getting where if one screw was taken out for the other, it would cause the camera to be tilted slightly, and your image wouldn't be fully in focus. It would be partly in focus. So now the method is crank them all the way down, all 4 of them, and the image will be in focus. Oops. And I keep this back cover on. It is plastic, and it actually has melted. I've melted this back cover, so there's a good chance it'll melt, but as long as you have all 4 screws in, it should be good to go. So the camera should just slide in there with very little movement. And we're going to start these screws. The screws should go in pretty easily. The holes are sized fine. They will start to not strip. You can only tighten them so far before they just spin freely. So you can only really get the camera to its max tightness. You're not going to pull anything through, I guess. But these small screws only engage enough to get it tight, but not to like pull it off balance. I guess is what I'm trying to say. Yeah, sorry about the fucking gimbal. It's pretty dumb. I don't know why it does that. So I'm trying to not bump the desk or the gimbal system. But I just tighten these screws. As much as they'll all tighten, they all poke out pretty much the same. The sensor looks nice and level with the surface of this cap, which is what we're looking for. And our cap is assembled. The great thing about this cap style is there's no screws. Actually, there's like some alignment marks on the side. You just line these alignment marks up, and your cap should snap into place. and it snaps in. Once your tube's assembled, that pressure is going to hold it there. It's going to hold it flush, and you're good to go. And to unsnap it, simply take a pick or tweezers or something and insert it in the this area right here at the top where the actual locator pin goes. Just insert that there, and it'll pop right out. So we're going to set our cap aside, and we're going to go to the display. I'll set that. So I'm going to try and do this without fucking getting fingerprints on the display so I can clean them later. But your display is going to feed through, and it's going to get glued in place right there. The board itself is going to come in, and there's some like rails for it, and it'll go in those rails, and the tension from the flex board pushing back will kind of lock it in place. But we're also going to put some glue in the corners of this board just to hold it where it is. And if you want to pot your tube, you can do that through these holes in the front. I typically don't do that because it's basically unserviceable after that, and I don't trust these electronics enough to say that I could pot it and never have to fucking re-solder a connection or something like that. Maybe if I pulled it out of a unit that I've been using for a while and it hasn't had any issues, then I would, but I just personally don't have enough faith in these to do that. I want to get to a point where I have that faith. I'm just not there yet. So what I'm going to do is I'm going to bring it so the display is only kind of poking out, and it's kind of leaning forward like that. And I'm going to take a small chunk of hot glue, not too much. And this isn't like school, it's a special like resin-based hot glue. So when it's fucking hot, or when it's cold, it's cold. The V3 is up on my website. It's just the MX69 kit. V3 is all I'm doing now. I just went away from the V2s. Grab the hot air gun, and I'm just going to melt this glue. Trying to keep it in place. Jumping around a little bit. This was probably too much glue, but it'll work. Just gonna put that display in place. There's a little bit of play left and right, and we're gonna center that as best we can. I'll try and tune this gap out so that way there's only one spot for the display to go. But you're gonna bottom it out this direction. So freaking A, force a little string of hot glue and lay across the display. You're gonna bottom the display out in that direction. So this is how we're mounting it on my fingernail on each side. Get it in the middle. Best I can. Alright. That orientation is pretty important for the actual the function of it. That's going to affect your collimation and collimatability. And when people ask, like, can you collimate these? You absolutely can, but it's just hard with, like, the tooling. Everything's printed and hand tooled. It's really hard to get that precision you need to collimate. I'm going to have to wipe that off with a Q-tip or something later on. A little bit of glue on the screen. Alright, so then when you insert this board, you're going to make sure the camera can watch this. It's important.
going to push this like that. So the board makes a loop, not a tight loop, but a loop. And then I grab something like these, like tweezers, to set the board, the top of the board in place. Like I said, there's these like slots, and the board pretty much gets locked in. Like it's not recoil resistant right there, for sure, but it's pretty much locked in place. That board's probably not going to move too much. And what I'm going to do is I'm going to super glue that board in place after the next step. So the next step is going to take this MX69. We're going to bend it at the cut to make this kind of L shape right here. And we're going to put it in, stick a corner through, and pull it the rest of the way through. And this part is pretty important, but you're going to want to get the pads almost over this gap when you glue it in place, and you want to center it as much as possible. The actual board has a little indent to let you get this flex board in multiple positions, and that's just going to depend on your actual build you do yourself, where you get your contacts lined up at. But I put the contacts as far forward as I can and try and keep them centered with the display. And once we know that that's where we want them, we're going to take some Gorilla Super Glue that is glued shut, and we're going to apply to the board, not to the tube. We're going to apply it to the board, and I'm just going to fold this back. And it takes literally none, but you want to make sure you get all the edges. So I'm not even applying more glue, I'm just wiping the glue, because I want to be able to make sure all the edges are secured. So it's barely any glue on there, but the edges are all secured. Not too much that you're going to be overflowing. So from this point, I'm going to get this lined up as best I can. I'm going to press it down, make sure my contacts are over that gap, like I said. And I'm going to run it from the inside out. So I'm going to push on it with my fingers. You're going to get some glue on your fingers. Try not to get on the pads, but even if you do, you can scratch that off pretty easily with your fingernail. And that should hold relatively quickly. You're going to assess it for straightness, and you can peel this up, it'll peel up. The super glue bonds to the nylon, but not like a crazy bond, so it'll peel up. You just got to get something under the edge. But I wouldn't recommend peeling it too many times, because this board can tear, and it'll get kind of like bent up and flimsy and awkward the more you do that. And then we're going to take our camera cable, or a display cable, and this is a tight bend, but we're going to bend it almost into a U shape, and we're going to insert it in the bottom. Let me stand up so I can get a better view on the camera. So we bend this basically into a U shape. I'm going to use the tweezers to help me push it in place. Just make sure you're going straight and make sure it's lined up. Sorry, it's not focusing. There we go. And it does got to be fully seated. That's fully seated right there. So just to recap our wiring, we have CVBS, we have brown, well, purple actually is our voltage, then we have our brown going to there, and we have our open connections for our up-down brightness that we pulled those pins out of. And when we actually put the cap on, what happens is these wires will push and it'll roll all this in there, and there's no chance anything's going to short, because remember we covered the backs of those pins, and those pins are actually in a place where they're unable to touch anything, so it's really advantageous. And now we're at the point where I would normally glue this board in place. So the board kind of came loose a little bit, but you want that board up in there as much as you can to give as much room for that camera as you can. So the board sits at a steep angle. We're just going to push that board up in there, and then I'm going to apply super glue. Let's see if we can focus it in that corner and in that corner, and that's going to keep that board locked in. And once that sets up, that board is locked in place. So this is pretty much done at this point. The only thing is we're going to twist this cable up. Don't want to pull on that too much, so I don't want to pull that board out of place. We're going to twist this cable up, make sure everything is actually going to fit in there. And we're going to find our board. We're going to run our OSD through this top right. And it's like close, but you can't just push it through by the wires. Get something to push on the plastic, and push it through, and it'll go through. And then we're going to connect our camera. And I like to support this a little bit from the front, just because it's a tight push. And then I like to twist this cable, and I'll twist it until it's like a tight wind, and that just makes it more rigid. I'll just hold it like this for a little bit, just to let that cable gain that memory, and then I let go and it's a nice tight wind. And we're going to do that to the back as well, but I'm going to pinch it here so it doesn't wind too far back. And we're just going to twist this end, and that's going to let that cable be more compact, and we have some serviceability room inside the tube itself. And that cable is going to fold over on itself, and as you close it, everything's going to set back into place. And then our cap's going to snap on. And that's exactly how you do that. And that's pretty much the build. So what we're going to do now is we're going to test it. Step one of testing, we're going to set our multimeter continuity. Turn it on, check it first, because I've had it before where this is like slightly pulled out or whatever, and I'm fucking around, I'm like, why isn't this working? And then I'm like, it doesn't beep, and I'm like, oh wow, I feel retarded now. But we'll check our continuity, and there's a little bit of super glue on this pad, so we'll scratch it out with the probe, and this is what we should see. 0.493. That's the continuity we want to see with the OL51 board, and with the display connected to 3 volts. If the display is connected to the boost converter output, we're going to see like a 0.2 voltage. So this one is with the, I don't have the other board. I'm sorry. I was going to show you with the other board, but I don't have it on hand. Good morning, Friday tomorrow. The OL51 boards seem a lot more versatile, so less likely to destroy them. Sorry, these glasses give me a weird depth of field. I'll switch these lenses out to lower power. I can only see with these lenses. I can only see within like a 6-inch range, and that's about it. Alright. So, yeah, I have my you guys can't see it, but I have my power supply set up. It's at 3.8 volts. We'll just verify that via the multimeter. So I'll just set it to DC voltage. And we'll just make sure that it's actually 3.8 volts. Supplied, 3.78. Alright, 3.78 volt supply. And we'll go ahead and try and power this up. I'm going to tip it up so you guys can see what's going on. And we have a blue screen and then a what looks like a white screen. It's not actually white, it's just what the camera's seeing right now because there's no lens on it. So we have a working tube. That brightness of the display, it's going to depend on what you want. That was a pretty decent brightness for me. I'm okay with that. Yeah, that looks like a good brightness level. That's not overly bright. It's not very dim. You'll be able to tell if it's too bright or too dim. And if that is the case, like you're like, oh man, that sucks. So just pop this back open. And you're going to connect one of your spare leads into the up-down connections. You can connect them both because there's chances are you're going to mess it up. And this end is already stripped, and you're just going to, while powered, you're just going to go tap on the ground to go up and down, and you'll see it, it'll visibly change. The steps are pretty large, so it'll be quite visible when the brightness changes. Snap that cap back in place and you're ready to rock. Use an Alpha 2 housing real quick. I just want to let you guys see that it works. So I'm going to disassemble this one side. Take this intensifier tube out. And the Alpha 2 has wider space contacts, which is ideal for the MX69 version 3 boards. It's the perfect spacing. I'm going to revise these boards as well to make the contacts even larger, because like you're shooting at a real small target area. There's no reason why we can't just make these contacts like fucking huge, so that way you're not having to guess. Because it turns into a lot of guess and check when you install them. You're like, did I put it too far forward? Did I put it too far back? And it just kind of gets real tedious sometimes. And I know Emmanuel Matthias can attest to that because he explains his frustrations one day. I was like, yes, I get it, dude. I got the same problem. Alright, so we're going to set this back to continuity. I like to do this every time. And we're going to turn this pod. This pod will have no connection in that stow right there. And we're going to test this Fisher port on the back to see if our pod is working. I'm just going to install this lens so it balances. I think I just push the camera. Oh, one thing I forgot to note, when you're installing it, watch out for this pigtail. It'll get caught in there, and then it'll prevent you from fully inserting. But there is in the Alpha 2, there's a undercut in here that you can stow this cable into once you have it programmed. I'm not going to stow it quite yet. I'm just going to kind of push it down against the surface of the tube. So when I put this lens on, I can feel when the lens contacts the tube. Contacts it right up about there. So I'm gonna keep the lens right here, and that's just to have something to balance on. This tube getting pushed out. It's like getting pushed out for some reason. I can feel it. Alright, we're gonna leave it right there. We're gonna check our continuity. So on the Fisher port, when you're looking at it like this, there's a ground plane right here. That's your ground side. And there's a non-ground plane, and that's your positive side. We're going to check that continuity. These have continuity themselves. not to the pod, not to the connection. And sometimes it's actually the fisher port itself is like a little weird. Like you can't get the probes at the right angle. They're too close to each other. So I'm gonna go ahead and stick this against the battery spring, which for some reason is like stuck in there. And we have no continuity. Battery spring got like mushed in there. That's weird. Fucking O-ring came out. Alright, so we don't have continuity for whatever reason. And that's when we get into the whole troubleshooting and trying to figure out what it is. Typically, it's the tube's side-to-side rotation. So the first thing I do is I look at the top and I make sure that this connection is actually dead center with this board. And the best way to do this is like basically get like an aiming tool and look at it. So we're pretty much dead center. That should be within range. And the next thing I do is when I'm inserting it, I'll only look at one pin. So I'm only going to look at the positive pin and line the positive pin up with the positive on the tube. You guys aren't going to be able to see this, so I'm just going to kind of do it at my own advantageous angle. And then another thing is to make sure you're not twisting the tube as you insert it from what you wanted your alignment to be. So it's probably impossible to catch, but the tube turned like that to hit that alignment mark as it sat in place. So just be mindful that there was a small amount of rotation, but not a crazy amount, so we don't like keep doing the same maneuver and wondering why the fuck it's not working. So we're gonna go back to testing the fisher port. And we're looking for that magic 500 number. I'm gonna give some pressure to the tube and kind of wiggle it with my fingers just to see. My fucking butterfingers are sliding around. And I want to basically grab the tube, I'm gonna work it until we get our spot. So it looks like I put my tube contacts too far over the gap. So I actually have to pull the tube out about a millimeter for it to make connection. And that's where we get our good connection. And that could be because there's super glue on the ground plane too. But when that happens, because it's happened before, I'm going to find an O-ring that is not bigger than the tube diameter. And I'm going to put it over top of the OSD. And I'm going to tuck it in and on that front plane of the tube, and it's going to act like a shim, and that's going to keep the tube the back distance that we need it without having to rip off and reglue that board, which we absolutely could do, and that would just solve the problem. I'd rather just shim it and call it good. And this is like going to be on you guys to be able to do this kind of like analysis to figure out what needs to be fixed. Which, if you saw me moving that tube, that's a pretty good way to check it. Because you just keep running it until you get your connection that you're looking for. And I'm just lining that O-ring up so it's gonna work. Alright, so we got our O-ring in place. The tube is pressed in. Now we're going to double check our connection again. No connection. Maybe this O-ring isn't big enough. Maybe the rotation is off. that's our rotation right there. The O-ring still just isn't quite enough. See, when I let go, it's got it, but as soon as I put that retainer in, it's going to press that tube down, and it's not going to have connection. I think what we're actually running through that ground plane has that super glue on it. So, because I can see where the spring's been contacted. I'm just going to buff this off with the probe. Taking that gold off and put the cap on because the gold will scratch off pretty soon anyways if you have to do this too many times. I just want to get that as good as I can. I'm going to line up that O-ring's in there, but I'm just going to take it out and actually replace it with a little bit bigger O-ring. This one's a little thicker and bigger around, so this one actually works as a good shim. And I'm just going to reline these contacts up. We'll run that tube in there. And check our continuity again. So we're getting nothing. Pick it up and move it. Our rotation amount, and I press down and we're not losing connection. So that's what we want to take. We're going to take that key retainer and we're going to retain that digital tube in there. And I just like to do this because sometimes that retainer can put a little more pressure than we expected. Check it one more time. We still got our connection. I don't have a CR123 battery pack. Work for this. I do have an AA battery pack, so I'm expecting to get power on. We'll see what double A's will do. Alright, so we're powered on double A's. That's a first. I haven't seen that before. Sweet. So, without cleaning this, because I just don't care to clean this, it's not going to end up in this housing. I'm going to tighten this back on. Yes, Alpha 2s have an internal battery. For some reason my battery spring got crushed in here. It's like, there we go. Basically, I ran into a small problem with Alpha 2s. That's not a big problem because it solved two issues, the fix I did. But basically, your battery, when installed, can short out, or could short out, on the positive contacts on the Fisher port. Let me grab a board, for example. The battery could short out on the pins that came through that Fisher port. So what I end up doing is, once this is all in, I just pot the inside of that and install this O-ring. It's an 18mm OD, 3mm thickness, and that way there's no actual way the battery can physically contact. But I think I installed the battery too soon and I glued the spring in place. So I'm not sure that this internal battery's work quite yet. Alright, I'll put that spring up a little bit so it might have some contact now. But let's see where's the battery can. Alright, so we're powered on. working. Let me grab a lens. This one's a 12mm lens. It's not the 8mm, but it'll work. And I'll take these glasses off. Trying to see if I can get you guys to get the first view. Alright, this one has a pretty shitty back focal length, or maybe it's just because it's... Let me look through this quick so I can focus on. So this lens is focused. It's not going to focus too well on the desk, but the objective lens is focused. Sticks out too much. This is the 12mm lens, so it's not actually meant for this. 12mm is like an experimental size I did that I did not redo for obvious reasons. It's got an 8mm lens. So here's a fresh 8mm digital lens. And the point at which this one focuses is pretty much right where that O-ring starts to seat. That is going to change. And it will seat here instead. I'm working through some modifications to the 8mm lens design. I'm going to focus this on my wall real quick. Alright, and here we have it. We're in 16:9, so the image looks crazy right now. So the first thing I like to do when I get a tube working is I'll pick this OSD out. And I run the OSD out the front because the cable is long enough that I can plug them in. And I'll usually, I'll have 2 tubes plugged in. And then I'll adjust the settings. Let's see if this is going to be too shitty to do the camera or not. I'm going to adjust this focus. Alright, you guys probably aren't going to see too well what this is, but I'll go through it anyways. So here's system. First thing I do is you see cam title. Cam title's off. That's the system. We're going to change that to PAL. We're going to change this to 4:3. Go to return. I'm going to go to exposure. I always turn brightness all the way up on the exposure. You can set that how you want. The old way of doing it is I would set this to manual by clicking the side button. I'd click on it and set it to 1:50, but it pretty much always just does 1:50 when it's absolute dark anyways. So I just keep it on auto, just because it'll dim that image down if there is lights, or if you run it in the daytime. And then I'll go to image, and I like to turn the sharpness up. And the gamma, it pretty much always comes at 0.45, but that's where you want it, is at 0.45. Don't mess with any of those settings, and then you back out, and you go to exit. Now we're going to power this off. I'm going to power it back on. I'm going to go to systems, and I'm going to verify these did not change. The biggest improvement you will gain in systems changing is NTSC to PAL. That's the biggest single hand improvement. If you're going to do one thing, do that. And that is pretty much what you need to do to program the settings. And then we're going to remove our OSD. I'm going to make sure this cable is nice twist. I'm going to tuck it down without trying to touch the sensor. If you do touch it, get a smudge on it, that's fine. The sensor itself is protected by a tempered glass window, so you're not going to scratch the sensor and damage it. That tempered glass is not going to scratch. It's pretty fucking solid. but we're going to tuck that in, get it out of the way. Take our 8mm lens. I don't have the D-collars in MJF right now. They didn't turn out in the last batch, so I just threw them away. They were like 10 sizes too big somehow. And yeah, so that's probably focused for me. Yeah, it's just not focused for the camera. There we go. That is how you build the MX69. It took us about an hour, probably mostly just because I was explaining steps and trying to show you things. But I can do these in about 45 minutes per tube. And then, you know, install time after that. The fact that this fired up on AA's, that was kind of cool. That's pretty cool. That means that well, actually, this might be a fluke. This is a L3 battery pack, not an FMA one. Let me try an FMA one. Because L3 might have like a electronics inside that the FMA one doesn't have. So we're just gonna give it a quick check. Use the same batteries though, just to keep things consistent. To go to extruded tubes question about how much they weigh, I can weigh this one in a second, but it's not going to be a great example because it's got one intensifier tube and one digital tube, and I don't feel like building another digital tube. Alright guys, so it looks like this only started on an L3 battery pack, so that leads me to believe L3 has some voltage management stuff built into their board. Or I'm retarded. Did my FMA battery pack shit the bed? I think it did. That's not ideal. What happens if I just squeeze this in place then? Alright, FMA battery pack broke. That's sick. I have another one. Jesus Christ, these screws are way too long. I will say that the Alpha 2s with analog tubes and Chinese, the CK Optics glass, it's about the weight of a katana, a little bit heavier than a katana with lightweight glass. Alright, so it runs on an FMA pack. So, well, no, it doesn't run. It just short cycles. So I get a lot of questions about troubleshooting, and that's one of the biggest things that the issues that people have is they're like, hey dude, I just got these in the mail and they don't turn on. So most people will just throw in, they'll go to Walmart because they're excited and they didn't plan ahead, and they'll grab a CR123 off the shelf at Walmart, they'll pop that sucker in there, and they'll power it on, and they'll be like, yo, nothing. And then they'll message me and they'll say, hey, I can't get these to work. What's going on? And I ask them what battery they have, and they're not using the right battery. It's literally that simple. These batteries, this one might be dead. That's probably why it didn't do anything. But the rechargeable batteries put out considerable more voltage, and they have a higher current rating for our high draw that we have. So we have 4.17 volts on this. This is probably a dead battery. 2.96. Let's see. Ooh, that's shit dead. If you want to buy a pair, they are on vonschriffarms.com. This one's 3.16. Let's see if we can get some startup on 3.16 volts. They're on vonschriffarms.com. You can buy them digital or with analog tubes. It's your choice. Nope, won't even start on 3.1 with the analog battery, or a fucking regular battery. And I have done this before, so I know it works. But boom, get that digital analog fucking combo. This would be weird as hell. The only reason you would do this is to compare the 1-to-1, which it's not going to be a good measure because this lens isn't even in focus. But like you can just see this screwdriver handle in analog. Same handle in digital, real life handle. Yeah, I would say that that's a fair representation of the digital to analog size. It's pretty close, but it's a little zoomed out, and that's with that 8mm lens, and this is the standard PVS-14 optic. I have here a this is one of the 58-degree lenses. This is the eyepiece, 58-degree eyepiece. And these are a 19mm focal length, for anybody that's wondering. I don't know if it really equals B58, but it's definitely more than the standard. And so I'm not going to put it in the diopter housing. I'm just going to stick it in there just to give it a focus. That's a tight O-ring. But you can see there the size of this screwdriver is a really good match now. I wish I could get a better example. Look at that voltmeter. That's a pretty good match. It's better than the better than this one. This is a 26mm. This is a 19mm. It also changes the size when you put it further and closer from your face. And it kind of has that effect with the camera, but it's more noticeable with your face. But yeah, so I like these 58-degree eyepieces. The only problem is they're like twice as expensive as the regular ones. I'm trying to work some low-cost options that are better for us in the digital side. The color filter that turns green into a white false effect, it's just an effect, is going to be the one that's marked white. And it's less noticeable here in the daytime, but at night it really helps. It also helps remove brightness in the scintillation because it filters out fluorescent light. And let me see if I can pull one. So here's a blue one as well, but it just has too much of a blue tint to me. I like the blue one on the digital. It just brings that image really close to like an L3 white floss effect, so I like that. But it doesn't look very good on the green, like in real life. Whatever the camera kind of makes it look like. it looks kind of terrible. It's like it just turns it into a deep green versus just a green. Whereas this one, the purple mutes out the green tones, and it looks, yeah, it's purple. It, to your eye, it really mutes those green tones. You can see it's not like super purple, but it's purple compared to the blue. The blue cuts down a lot on the actual transmissivity of it, so it darkens it way too much, and it just turns it into a deeper green versus like a you can see kind of like how that the green on this voltmeter turns more yellow. It kind of already looks yellow. Here we go. So I'll show you this effect. So it doesn't do too much to this actually. All right, that was a stupid fucking comparison. Anyways, guys, that's it. That's the fucking digital tube build. Shows it working in the housing, and yeah. Like I said, the MX69 kits and the mono kits and the battery pack kits are now shipping next day. The Alpha hardware kits are not shipping next day yet, but they will soon. I'm waiting for a fucking shitload of lenses to show up, and then yeah, we should be good. Those will be ready to start going out soon like that. If you guys have any questions, now's the time. Just because I know you guys want to see something cool while you're pondering whatever questions you have. Boom. Some freaking white phos. These do have irises on them, so I'm not worried about them. But yeah, these right here, I am working on building out some stock, and I will have probably 2 to 3 sets of white phos alpha 2s ready to ship at any time, and that's going to be around August when those are ready, and I'll have basically ready to go. Price point on those is probably going to be $4,300, so don't quote me on that because that's just off the top of my head, but $4,300 for some white phos duals. Yeah, dude, the first MX69, here we go. Oh, wait. Here's the first one. Some fucking wild brass that was bent and shaped and cut. This one is potted, doesn't work, I don't think. It's been a while. I like to keep a lot of my prototypes just cause, but I'm pretty sure I shit the bed on this one. It I left it running for like 3 days, and then it just didn't work anymore. We are getting amp draw. That's weird. But we're not getting power on. Yeah, that one's not gonna work. This one will work. The screen came detached on this one. Thought this one would work. There we go. Here we go, an old working prototype one. What else do we got? We got this fucking wild one too. Not working. These ones do not work. Yeah, they got a lot easier, a lot nicer, a lot cleaner. These flex boards. Here's our first iteration of flex board. Don't have any thermal tubes out. Where's my thermal? Here is the thermal. This one specifically is using a FLIR boson, but you don't have to go with the boson. You can go with the I-ray. I'm trying to find the here's the thermal tube parts. This is the MX69 V3. I shortened it a little bit because I brought it. It was a little longer than an analog tube, and this will work for the camera one as well, not just the thermal one. But the only difference is the cap bolt pattern is slightly expanded versus the Night Eagle one to accommodate the thermal. And then I'll just disassemble it because, you know, why not? This is a 320 boson. It's really out of focus, so anything past like 2 feet looks like garbage, but close in it looks great. But I gotta adjust the focus on it. Here is the boson. It's in an FDM printed pod, but you can see it's got the same MX69 board. Without prying on it too much, the wiring is basically the same. It's got 4 wires coming off the boson. It's got 2 grounds, one for video, and I just connect that one up as well. And I connect the video ground from the board as well. Oh no, my display board came out of place. But the wiring is basically exactly the same for the boson and for the I-ray. The I-ray has the same bolt pattern as a boson. The only difference between the I-ray is the outside diameter of this lens. So when it comes to this part right here, which I just call the plug, it just is a little bit bigger for the I-ray. I don't have the O-rings in here because I was lazy, but this part would take an O-ring on the inside and an O-ring on the outside. And when you slip that in place, you tighten your D-ring down. That provides some clamping force against this shoulder on the camera, so everything gets clamped from this side and from here, and not just here, so there's actual pressure on the camera itself. This is just a regular mono tube, so this will actually run in other night vision devices, like for example, I can pop it into this LLUL and line up the contacts. It's probably lined up, but it will run in the LLUL just like that. This will not run without being on a CR123 battery pack, guaranteed, because it draws so much more power than the regular digital tubes. So I'm not even going to try and fire that up for you guys, sorry. But yeah, that's the thermal tube. The assembly is almost identical. The only difference is that plug right here, and that just goes in afterwards. You drop your tube in, same as you would. Line up your contacts, you push it in. Verify connectivity. I'm just going to turn the battery on, see if I can get it to power on. Whatever, you guys get the point. That's pretty much how it goes together. The housing is the same as any other housing, just the special thermal tube. If there's any other questions, shoot those questions to me now, because I'm tired. No, I don't know anything about a PTS 233. There's like a myriad of things that can go wrong, which would make it seem like the display is wrong. So I wouldn't say it's just a display. One thing I will say is, I get asked this a lot, is can you weapon mount this FLIR? And no, you cannot. There is an accelerometer built into the internal components of the boson, so when it's smacked or recoiled, it will cut video feed, and you have to power cycle it to turn it back on. And I thought this was my doing. I thought I fucked something up, because I was like, yo, if I smack this too hard, it turns off. And then I realized it's still shuttering, it's still running, it's just not putting video feed. and I talked to someone who's really smart on this actual componentry in these thermals because he's worked with them, and he said no, like State Department required them to install this, so they can't be used in bootleg weapon sites around the world. I'm trying to get this fucker turned back on. So I can just demonstrate the smack. Got these contacts lined up on the older boards. This has the old board installed, the old tube PCB. The new ones are so much nicer, and you guys are gonna thank me. They come on a flexible sheet like this, and I just solder a bunch of springs on, solder a bunch of leads on, and pop them off. They have a wider spacing, and they account for the curvature, versus the flat boards didn't. And the reason why I had flat boards is because all I had for tubes when I first started was the large ground plane tubes that the ground plane actually encompassed the positive. So I got away with a lot smaller tube spacing, and I didn't even know that these existed. And so you can see I put copper tape on here, and that's to actually extend those contacts inwards to work, because I didn't know what that spacing was until I got those tubes, and I'm only now making the switch because I'm tired of using copper tape. Let's see, can we get some connection? Yeah, dude. Thermal is the real superpower. Like, night vision's cool, but thermal is where it's at, because you can hide from night vision pretty easily, but thermals, there's a reason why the US government is really trying to get thermal camouflage, because it's a fucker. I don't know why this tube's not making fucking contact. Probably just my shitty probes in here. Alright, there we go. Not gonna mess with the position. Just tighten this ring in. I just want to demonstrate that smack on and smack off, we'll call it. So it's powered on. Video feed is cut. Display's on. Video feed is cut. So, yeah, you can bridge it with an analog because you just swap it into a housing, similar to how I just showed the Alpha 2 bridged with an analog tube. It's very weird, and it's not super Gucci. I'll just put it that way. Because when you pair it with an analog, the color palettes are so crazily different, and you can set the boson color palette pretty easily. You download a web interface or a computer interface, GUI, whatever, I don't know, and you just plug your boson into your computer, and it's super simple. The I-rays, I have not been able to change color palette, and those are a white hot. I would prefer them to be a black hot, and they would bridge with duals very well if they were black hot, but the white hots do not, because it's almost opposites the way everything kind of actually turns out. But it's pretty hard to bridge this with a freaking analog, which is where this sucker comes in. So this thing's obviously there's nothing installed in here right now. There's some stuff installed in here. The beam combiner's not in here. Let's see if I can get this fucking beam combiner out. Alright, beam combiner is gonna be smudged as fuck. This is not obviously a final product by any means, or even usable, but it's okay. The thing is I ended up having this lens. This comes on like some of those 0.3-inch displays sold on eBay. I just had this around, and it ended up being the perfect focal length, and it's held in with an O-ring. It ended up being the perfect focal length to work here. So the basis of this project is there's a fucking razor blade magnet on. We have our thermal on the front. That pushes to an MX69 board, which is jankily rigged up right here. We have, for some reason, a little piece of metal right there. Our OL51 board, our 0.5 inch display, to a 45-degree mirror, to a 50-50 beam splitter, or beam combiner, depending on who you are. So, see if this sucker powers up. It might. Alright, so we have power, thermal overlay. It looks pretty good right now, but parallax is a bitch for this. So when you're looking at it with your eye, those focal fields, they don't interact well. And that was the boost converter overheating. This sucker right here. Oh yeah, that's hot. I don't know how to stop those from overheating other than just doing something different to power these. So the bosons take 5 to 26 volts, so I might actually just run some in series and buck down for the display and just say fuck it. But yeah, pretty much works. Oh, is this the thermal? Thermal and thermal. So it gets a little muddied out there. And that size difference is affected by the position of this lens. So it went into thermal shutdown again, but, or did it? It just shuttered. Yeah, it's not running properly. And it's not the battery, it's the boost converter. Because I've tried different batteries, it does the same thing. It'll run for a couple seconds and turn off. But yeah, that's basically the overlay in a nutshell. Throw it on an analog tube. You'll get a couple seconds of view on it when it turns on. It's not turning on. Alright, that fucking thing is hot. Can we get some video feed? Nope. And optically, it's pretty shit. Just like I said, the parallax is basically if you put these two here, the images will line up if you're looking directly right into it. But as soon as you get any kind of tilt, they just shift. But they don't shift together or anything like that. They shift like this, just because the way the mirrors are set up. It's hard to explain. But like, if you're looking at your hand, the thermal overlay will go this way, and the night vision will go that way. Or it just looks crazy. They just kind of do that. And yeah. You could potentially put it in front. I don't know 100% if that will work. Haven't tested it yet. And oh, this is what was shuddering, not the other one. What I have tested is actually putting this in front, and you can kind of get it to work. So it could potentially work. The only difference is we'd have to put the beams combiner in the other way. So we flip that. This should project our image the other direction. The only question is, will we get an image? Okay, we're getting something. Not exactly sure what I'm looking at. Oh, it just turned blue. Yeah, it's not really working. It's just because the fucking thing is so hot. Oh my gosh. And yeah, I don't really know how to fix that, to be honest. I'm gonna do something crazy. I might try this display. For science. Wait. just turn that on. See, we are getting something. Oh, I feel so stupid. It's shining back at me. Oh, now I feel real dumb. It's not as simple as flipping around as I thought it would be. But yeah, it could potentially go in front. I just haven't really worked through that yet. I'm still trying to get the fucking thermal to not shut off for whatever reason. It runs fine in this, but it just shuts off on that one. Maybe that boost converter is just bad. Anyways, guys, it's fucking late. I'm tired. Yeah. All right. Any more questions? Last call for questions. If you guys are looking to buy some night vision, I have a couple monos ready to go. This one has the 58-degree lenses on it, but I was going to put 40-degree lenses on it to actually sell them. Let me know. You guys might also like this, the old PVS 31. It's the first look at the Alpha 31 kit. It's not going to be a sold housing, it's just going to be a kit. This is an FMA bridge that I converted. These are the 3-1 pods. They are fixed diopter. There's going to potentially be some diopter inserts, which will just be like really weak lenses installed into the diopter insert parts. Right now it's just got purple filters in there, but they are stow off, so they turn off. This set right here, I actually used these stow off boards to create a switch, which I thought was super clever, because at the end of the day that stow off board is just an on and off switch. So just made a rotary switch like that. You turn it this way, it turns on. Turn it this way, it turns off. And yeah, pretty proud of that one. Let's power these suckers up. That one's got a weird connection. Yeah, so we turn the switch off, on, and don't mind the lens. I got hot glue all over it and I burned it a little bit. Yeah, pretty friggin' sick. They feel awesome. They feel pretty real. They got a really nice focus to them. It's very smooth. This is not manual gain, but the 3-1s will be manual gain. They're going to be just like a PVS 31. You push the button. It doesn't click or anything. You just push it and you feel it. You're like, okay, it's on. And then you'll have your manual gain adjustments. I think it's going to be 12 steps for manual gain. So it's really only going to be 12 adjustments. But we'll see. I'm pretty excited for it. So once I'm caught up on orders, which I have currently in my queue, I have 47 orders. Those 47 orders are probably going to be knocked out this week, and the 3-1 Kickstarter will go live. I'm going to go hard with it, and I'm going to post everywhere I can, just to let everybody know that it's live. The Kickstarter's got a few different reward systems. There's a commercial license, and there's a private use license for the files with it, and that's going to be one of the Kickstarter rewards. The current price, I had the private use license set to $100, but I'm going to back that down because that seems kind of way too expensive. But the commercial license is going to be kind of expensive, just because I know how the commercial night vision market gets, and whoever starts commercially selling these is going to sell it for fucking $12,000 because they're psychopaths. But yeah. So fuck those guys that charge way too much. But there's also going to be options in the Kickstarter kit for the housing. There's going to be the 1431 style pods or the fixed diopter 31 style pods with the 31 style lenses. So these lenses have an ultra fine thread to them, so they have a really fine adjustment. It's all custom designed in here and machined. It's actually a machined part that sticks to the tube. The glass is all custom made through CK Optics. It's just the lens manufacturer I normally go through. And they machine some special parts in here as well. And it's freaking tight, dude. I was so excited. These are just the prototypes, and the biggest issue is I didn't size these holes right for a heat set, so I had to jankily run some screws in there. So these pods are not held on very well. I could probably rip them off if I really wanted to, but yeah, I didn't do inserts, so I had to use plastic screws in there. Not ideal, but yeah, I'm really excited for these. But all right, boys, I am dog tired. The other last part, can't leave it half fucking spoke, is the battery compartment. This one doesn't have a working battery compartment, but this is the FMA bridge. I have machined battery compartments that I can't fucking. It's over. And the super glue like gassed off the plastic a little bit, but here's how it works. You get your spring, you drop in there, and that's actually glued in place. You solder your wire here. I'm trying to have these like brass plates made that'll fit on here, and you'll just solder this to the brass plate. And then the board in the housing will have pogos that come down. So when you bolt this on, it'll just pogo to this, and there's no like connections needed, just pogos on. But here's your battery cap, your fucking insert in there. You drop your AA in, and there's going to be a boost converter built into here. And that's the thing, is these are going to be pretty much only analog. They're not going to be super capable of running digital. I'm going to try and get some of these made that will take a CR123, but that might not be compatible with the internals that get put into it in the long run. And then I got these pano pods right here too. It is very, very watertight. So let me see if I can grab a couple components. So here's some of the basic components of the 3-1. This is your diopter set, essentially, and this will go onto the tube right here, and you'll just set that in. You can glue it in, whatever you want. I normally just put a little bit of glue right on the edge and press this onto your tube, and the height of this, which is already preset for a 0 diopter, the height of that will determine your diopter. Shorter would be a negative diopter. You could print taller ones and there'll be a positive diopter. That's your diopter adjustment. Here is the tube retainer. And this is a machined, 3D printed and machined part. I'm going to try and have these made out of aluminum, just because I don't have too much faith in the plastic. They take the same O-ring as the PVS-14 eyepiece, so the O-rings are all going to be supplied. Everything's going to be supplied with the kit. When you get this kit, you'll be able to just put it together. Not this O-ring, this is a thick one. So it takes this O-ring, it's a PVS-14 eyepiece, and that just throws into the pod. I don't want to get too much, I don't want to mess around with the pods too much because I don't want to get dust in them, but yeah, that threads in, and that creates a really nice seal, so when that's in there. And then this part as well gets an O-ring right there, and that presses, this is machined. You'll put glue on here and glue this to your tube actually, so I know people don't like to do that, but you glue this to your tube, or you can not glue it and just say fuck it, but this tube has been glued to before. You'll glue this to your tube, and this is going to set your collimation. So it's going to be weird. I'm going to have to figure out a nice process to collimate these once it's assembled. But yeah, this O-ring fits on there, goes against the machine surface. This right here is going to be a sealing surface, not necessarily like open and blank like that. So the hinge will have a silicone ring, or whatever we're gonna call it. Not an O-ring, gasket, silicone gasket. My brain's fried, I'm tired. But yeah, that's pretty much the assembly process for it. And your lens threads into that. It's not greased up, so I can't really put a lens in it right now. But yeah, it's stellar. I'm beyond excited for it. Alright guys, no more questions. I'm ending it here because it's 12:21. Alright boys, I appreciate you sticking through as long as you did. The MX69 is a lot less daunting than it used to be, and if you have any more questions, Discord is probably the best place to hit me up. I can't actually see message requests on my phone for whatever reason, so if I'm not responding, it's probably just because I'm only been checked on my phone and I haven't looked on my computer yet. But just hit me up on Instagram, Discord, Facebook, whatever. I don't really go on Reddit anymore because Reddit is toxic as fuck. But yeah, that's it boys, I'm going to bed.